Paul did not make it.
Yeah, he's flying. All
Oh,
right.
he's
Hello and welcome to the DCG development update. My name is Balázs, and we are here
Paul did
with
not
the
make it.
we are here. I'm echoing. Give me a second.
That was me. Let's not talk about it.
So we are here with the platform, mobile, and core teams, and we would like to give an update what happened in the past 2 weeks. We are planning this session for 1 hour, and if you have any questions or feedbacks, please let us know in the comments in the live chat below. And if you have a question dedicated to the Q&A session, please use a Q or a question prefix. Even if it's not a question, that helps us identify that it is intended to that session. All right, let's just start with the platform team and with Sam.
Yep. So very productive sprint. You want to share yeah, let's go. Um, Me and Lukasz, and very towards the end, Ivan, for review, have been on Mastnode voting. Good updates there that will come very soon. And Ivan also made a few nice PRs during his platform review. Paul worked on updating Dashpay.io. That was not actually the major bulk of his work, though. He worked a lot on the platform TUI and got DPNS registration working there. Oh, I shouldn't have given out the main content. Evgeny worked on the visualizer. We have some very interesting updates for StateSync as well. So let's get right in. Things are probably going to go a little bit more succinct in platform this week or this time, just because I anticipate more questions about a recent proposal that was just posted for acceleration of release. Okay, Lukasz is here.
Yeah, yes. So basically, Sam delivered at the beginning of the sprint a version of masternode voting that was good enough for integration with SDK, and I spent this sprint mainly on this topic. So basically, I implemented 6 requests in SDK to receive information about votes and how each masternode voted and all these small details. So we have 6 new features there. This is already in review. Hopefully we'll merge this, I think, tomorrow morning. And second part of this work is to do some testing of that solution. The PR that is in review contains only one test for each endpoint, but we want to have a bit better coverage there. So this is another task that I will work on in the incoming sprint. So it's just started. And also we had some bugs in SDK that we found during that work, and it's also in review. But it will be merged together with that SDK for masternode voting PR. So basically, hopefully tomorrow. So that's pretty much it on my side. Yeah, that's what I spent my sprint on.
Thank you very
Yeah,
much.
it goes pretty quickly when you say, "Oh, I did 6 different SDK query integrations."
Okay, let me
Basically,
tell a bit more about
no,
that.
no, no,
Just
no,
one
no, no,
more
no, no.
sentence, because it's not only implementation, it's also part of QA of the whole solution, right? Because it takes all layers. A basic test means that I need to start a local devnet and I need to send some query to see that that query is at least responded, and that's all tested. Right now, I will work on testing if the responses are actually correct and if that information that is in that response is what is expected. But like the primary flow, it's a full end-to-end test for the whole platform.
Yeah.
So we
My
had
only
some.
point was that like it's a lot of work, and I just did 6 queries. In total, the system only has, I think, like, what would it be, like 18 queries? So that's 1/3 of all the queries that the system supports. So it's a lot of work, basically. Thanks, Lucas, for the hard work this last 2 weeks.
Thanks.
Okay, so Masternode voting, where are we? Well, I was really hoping to have it merged in today. It's very close, but it's not done. Most is done though. So the things that were already done, I kept marked here as done, and then people can see how things have changed. So big things that have changed. The awarding went from 70% complete to done. The cleaning up and storing poll info went from 40% complete to done. The queries are done. The SDK integration that Lucas is working on is very close to being done. It's going to, as he said, probably going to be merged in tomorrow. The validation is mostly in review, and I mark it as in review because there's still some things that we currently have one bug left that I know of, and I'd like to take a little bit more time to add a few more tests of things that I'm not completely sure of, like edge cases, and that's why it's not done. The system works great. We have a lot of, like, for the normal case, we have tons of tests, like, just so people can understand how big this PR is. Without auto-generated code, it is 31,000 lines. No, 31,000, I think, from me, and 2,000 from Lucas. So it's big. And then with auto-generated code, it goes up to 93,000 lines. So yeah, that is a big part of the toll platform right now. So, I'm just happy it's over with. There's been tests for many things. In fact, let's go on to the other slides because we go a little bit more deep into it. So like all the queries, I'm marking here only the things that were not done. There are other queries, but they were marked as done in previous reviews. So like get identity votes all works now. Get tally information for a specific vote poll, that's all done. Actually, to make it even simpler for users, I integrated the finished vote poll information into the tally information. So basically, if you ask for a vote poll and you ask for information about it, if it's finished, it's just going to give you the finished information. If it's not finished, then it will give you the actual, like the current who's winning, and how many people are abstaining, how many people are voting to lock it, et cetera, et cetera, et cetera. And then we have who voted for a specific thing that was finished. Yeah, and the finished part is actually done. I was very worried about there being some limitations of GroveDB, but actually GroveDB worked perfectly, so there was no issue there. Yeah, we now award the document to the winner. We check for the ended vote polls, we tally the votes, and the locking of the vote poll is also done. One thing to note that I didn't write down here is that we have it so Masternode voter can change their votes up to 4 times. So you can vote once, change your mind again, change your mind again, and then you can only do it a certain amount of times. And the reason for that is that there's a cost every single time. And we don't want a specific attack where, since it's free for the voter, and it's on chain, we don't want them to just constantly change, and basically clog up the system. In core, it's done differently. It's not on chain, and it's also you have a limitation in time. For example, you can only vote, and then you can only vote again so much time after the original vote. That was also a possibility, but yeah, this is what we went for. So we'll see how it works. Yeah, moving on. Cleaning up. So basically, all of this voting generates a lot of data on disk. When it finishes, we don't want to keep all of that data. We do actually want to keep the data. We want to keep information about who voted for what. We don't want to discard that. But at the same time, we don't want to leave all the nodes for, specific queries. And we don't want to do that because for one little information saying like this guy voted here, we add, instead of just 32 bytes, it would probably be like 33 bytes. The identity ID and if they voted yes or no. It would be something like 100 bytes. So we're losing a lot of space. And this cleanup basically takes all of this and puts it into a little file that can later be queried. And that query works. So if it's finished, you can actually query the finished information that can no longer be modified. And that's the record. One thing to note, though, is that we do discard some information in some edge cases. And this is mainly because we could have a situation where we have somebody who tries to attack the system. So they make like 1,000 different options, and then they vote in a certain way that basically there are ways to do this. So if there could be like one vote or that's missing in cases that are somewhat like attackable. Now, do I think this is ever going to happen? No. And it's when I say votes missing, I'm not actually saying out of the tally that are created for finalization. No, they're all counted properly. It's just the record might miss some if we're under an attack situation. Not any normal usage could cause this. Okay, just wanted to let
Yeah,
people
thank
know.
you very much.
Yeah, so that's basically it for masternode voting. I'll pass it on to Ivan. Thank you very much, guys.
Thank you very much.
Thank you. Hello, everyone. This sprint, we continue to work on securing core RPC from platform and platform users. We already talked about this last demo, and you can see now more work what was done in this area. It's more on this particular slide, you may see the task related to DAPI. So DAPI provides some core endpoints, and the problem is that some of the comments not fast enough, and core RPC capacity is limited, so user can trigger directly, like not directly, but can basically calling the DAPI. DAPI calls in turn core RPC, and with some technique, the user can do some like DOS attacks on the platform nodes, overloading the core RPC queue and prevent other critical logic to basically to proceed, such as block production, for example, for platform. So yeah, we introduced some caching for get best block hash and get blockchain status. So it's caching for a block. We also introduced get best block height endpoint, because previously we saw people, and actually we as well, calling get blockchain status just to get the chain tip and height, and it's not very efficient way to do that. So we introduced a special pre-fast endpoint for this. It's even like not calling core at all, because DAPI has a global cache of the chain, like, and it knows what the current height. It's DAPI subscribes with ZermQ, and core just push the new updates to DAPI. So we're not using RPC for this. So having this, yeah, we updated the core stream endpoints as well to remove additional calls to core. And the last one is we had a pretty bad situation when a user using subscribe to transactions streaming endpoint and providing like Bloom filter to get back the transactions could produce like a lot of calls for getting transactions from core, and we replace it with the get transaction multi command, so that makes the streaming endpoint much more efficient now. We don't worry about it too much. Next slide, please. Thank you, Balazs. Yes, and also we introduced additional streaming endpoint, what we call subscribe to masternode list, instead of get masternode list diff Unari, it calls Unari endpoint, because this get masternode list diff, it produced in turn protx diff RPC call to core, which might be very slow, and it's very difficult to cache because user can provide any range of blocks to get the difference. And the idea behind the new streaming endpoint that we can utilize global cache for all requests in DAPI. So client, when it makes the connection to DAPI, we already have cached diff from the first block to the latest tip, and it goes to the client as the first message. And when new block arrives, we get notification from core about it, and then we just broadcast it to the open stream connections. So basically the user doesn't trigger any calls to the core. And yeah, and user getting the updates for new blocks automatically, so user don't need to create additional requests. So it reduced the load to the network and load to the core. This is in review right now. We also during our investigation, we found another problem. We discussed it previous time, that the user creating identity create transition with instant asset lock proof can trigger verification of instant lock signature for free from drive side, and that could be very bad attacks when you can get multiple nodes, connect this node to specific one as a peers, and then broadcast tons of these transactions on our tests. If you making like 100 verification of the lock with core RPC, the response time grew up to 25 seconds. It's probably just because of this core RPC queue delay, but it's not very good. So we made the decision to verify instant locks on drive side. If you remember, we already doing the same for chain locks. Yeah, to reduce the number of calls to core. So now we're doing the same for instant locks, but there is limitation. We verify only recently created signatures. I mean, it means like with transactions signed with recent quorums, due to limited information about the quorums on drive side. and if transaction was signed, like asset log transaction was signed with instant log, I don't know, like 6 hours, no, not 6 hours, 2 days ago, then the client better use chain asset log proof instead of instant log. So there are two types of the proofs what client can provide for the asset logs. That asset log is actually mined and confirmed on the payment blockchain. And so the idea is that if it's not recent as instant log, then client fall back to the reliable chain log proof, which always works, but it has delay, right? So what else? Yeah, we finished our test with the core PC queue overload. It was like theoretical part and practical, and we end up with idea to have two separate queues in core, so we can use the one queue for specific critical logic like block production in Drive, for example, and the second it calls external queue for some non-important logic like serving requests from DAPI, for example. So the non-critical requests, they won't interfere the critical processes for the platform. Thanks to core guys, Kosi and Pasta, this thing already done on core side, and now we're integrating it to the platform. Yeah, there are still some concerning part, to be honest. We probably will look at in other places, and we come back to you with this topic next demo. Thank you.
Thank you very much, Ivan. Sam, would you take over for slides?
Yes, for sure I will. I just got attacked by a swarm of termites. So I'll put up back on my video, but I had to move positions. So Dashpay.io. Yes, Paul has been working on that. So the Dashpay.io was built out a few months ago, and at that when we built it out, we didn't have all the features that we have now. So it's been updated to create contracts like we currently have. And it was also updated from GPT 3.5 Turbo to GPT 4. Well, it's not 4.0, it's 4.0. So yeah, that's nice. Go create contracts, guys. Tell the AI what you want, it will make it for you. In the TUI, he added the DPNS name registration for identities. So that's pretty cool too.
And since Ode is missing as well.
Oh God. All these people missing. I have to slap them when they get back. Good heart. Everybody knows that's not true. They're not. We all work remotely. My hands would have to carry very far.
That's the only reason why it's not true.
So yeah, so the state sync feature, this has actually come phenomenally far. So it worked, but it worked and there was a massive slowdown, right? We were doing something that we thought would go really, really quickly. And it was taking a very long time. We're talking about like a full state sync would probably have taken 1,000 years of a big database. So it was obviously, you know, we started reviewing. I spent about a day on this with Odysseus trying to figure out like where the slowdowns are, and we found a few. We fixed one, and I think it went 800 times faster or something like that. So, and then we have another big slowdown to also fix. So those are the two big things that optimizations that need to happen before state sync is released. The other one I think is that GroveDB gets closed and reopened on very often when it doesn't have to be. And that's the big other thing that's slowing things down. And after those things are done and the review happens, we'll be able to merge in state sync. Assuming that the proposal, I recently made a proposal, I think some people have seen it, for an accelerated release schedule. If that were to pass and state sync hadn't been merged in yet, all efforts would go towards that immediately. So state sync would be pushed out a little bit.
Hey, thank you very much. Let's continue with Evgeny.
Hello, it's been a while, and a very big list of updates here. So one major is web view for visualizer. It was shown before on demo, but now it is bundled inside GrooveDB. So when you use GrooveDB as a dependency with the feature flag, it will bundle the visualizer application inside of it and could be used just as is in your browser. And it's pretty neat. Also, what was done, as you know, path, keys, and values are all some sort of bytes, and path contain multiple byte segments. And previously, we couldn't select how each of these segments individually will be represented. And because bytes should be somehow represented, and for instance, identities through tree is just number 32, but next identity has an ID, and ID is way longer than just a number, and these things could vary now. So we can show for root tree, we can show just numbers as pass segment, first pass segment, and then next segments could be hex or whatever actually we have now. Hex, byte, arrays, assigned integer, and also variant support was also added. It was missed some time ago or one of the previous demos. Also, a neat thing we have now is jump to subtree. Like when we open multiple subtrees on the same level, and just not to follow these lines, we can click and jump into the action. Mostly that's it. And for the initial version, we planned also some stuff is missing, like some slightly bigger values, like data contract. It doesn't fit quite well within the node on the screen, so need to limit this. So it's a work in progress now. And a feature asked by Sam really madly is to have profiles, is to name identities not 32, but identities with the word. And because all the projects are different, because GrooveDB is like the first target is platform, but it's a general purpose library. We want to support profiles as a general purpose mechanism to make aliases to some arbitrarily pass values inside, and also to jump to them quickly and fetch them quickly. So it's also work in progress. And that's it. Thank you, guys.
And now let's move forward. Costa, would you kick us off with the core team?
Yeah, for sure. We can move on to the next slide here. So the biggest thing that kind of got worked on last 2 weeks is a metric ton of backports. That's always a good thing to see. Good progress was made on V21 and V22 backports. So one of the like things of interest that came out of that was improved I2P and what's called CJDNS support. CJDNS is kind of a weird name. I need to look into it more. It seems interesting a little bit. It's it is some type of semi-anonymization layer built with IPv6 in mind. So think of it somewhat similar to Tor I2P, but not exactly comparable either. It looks interesting. It was a thing that Bitcoin implemented, and it's necessary for our backports of BIP 324 to have done this first. Um, it seems kind of interesting, but I want to kind of look into it a little bit more and see what it really looks like and what implications it might have. So we also worked. I don't remember. I don't think I reported on this last sprint. I think this happened in the last 2 weeks. Eugene has a PR open right now, which should help resolve a lot of the governance non-determinism that we see on testnet. The issues that we see on testnet don't couldn't be seen on mainnet. It's really just because there's such a small amount of time on testnet between trigger and superblock. Because we have a superblock every 2 hours or so, the trigger only appears, very, very shortly before the superblock itself. And that gets sometimes bad race conditions where a node doesn't see the trigger for whatever reason, and then it sees the superblock first, and then it would mark the superblock invalid. So basically, what is happening now under this PR is that on a block which is chain locked, some of the more strict governance checks are kind of relaxed. And so the firm checks of, emissions and making sure that, funds aren't created out of nowhere, all of those are obviously still checked, but we're no longer checking that we actually have the trigger that matches that superblock, assuming that the superblock is chain locked. So this doesn't really affect mainnet or anything, but this should help resolve some of the kind of instability that we've seen in core on testnet, where every once in a while a node would fork off and we would have to go in and reconsider some stuff and do some manual work. This kind of will just automate that. And yeah, so all of the other stuff is basically pretty similar to where it was at. A lot of progress has been made on the BIP 324 side, but there's just a lot of backports in P2P refactoring in order to get us to that. So we're moving forward. We've made good progress. You'll see on the next slide all the stuff that was done, and I think we can actually. It's the slide after this, but real quickly, we added one Evo node, I think, in the last 2 weeks, so that's interesting. And the v20.x stats didn't change much. So we're pretty, stable into v20.1 now. We can move on to the next slide here. So yeah, here's the list of PRs done. As you can see, a lot of backports. Basically, all of these are backports besides like 6030 and 6051. So a lot of backports, good progress there. We do releasing platform in an expedited way would require a core release, and so we are, platform is, intended to bundle with version 21. So we are looking at starting basically the release process for v21 in the near future, starting to deploy it more aggressively to testnet. We already have some nightlies and stuff that we've been testing on testnet, but start evaluating that and get the network upgraded. And then we could have version 21 out within a month or so, or a couple of months, depending on what this timeline looks like. Even if platform is not expedited, we do still intend to release a version 21 in the relatively near future. But if platform is expedited, then version 21 might come out a little bit sooner as well. So I think that's pretty much all that I wanted to talk about here.
Thank you very much.
All right. Thanks,
Ryan?
Pasta. Yeah, so on mobile, the first slide. So it looks like a small scope, but it was quite a bit of work that was put into the SDKs for Dashpay. Still in progress is the actual creation of a username, which we're looking to get pretty close to soon in the sprint that we're in now. On iOS, also pretty heavy, load on the macros and the ferment system. Didn't quite get to the actual SDK for iOS. Hoping to dabble into that the sprint that we're in now. Finished up the Coinbase filtering, I'll call it, for users in the UK from using Coinbase. That was a requirement to get through the Apple Store review process. And a couple improvements on the home screen to group transactions by date, and a couple small crash fixes, as well as continue to work on CoinJoin for iOS. That is it. We are having a couple releases coming out soon for both Android and iOS with some of those improvements that you saw there and in the prior sprints. So thank you.
Much. So let's see. Question for Pasta. Would Core consider a simple click of a button, a UX upgrade, to do anonymous Tor communications in the Dash-QT wallet instead of a complicated console solution? Question mark.
Yeah, it's interesting. I would have to look into it more. I don't know how I feel about bundling Dash Core and Tor together. I know that other smaller projects have done it. I would be interesting to see if any other major projects have done it. I would be surprised if there's any, intellectual property issues. I think Trezor might do it, where they have the ability to just kind of one-click setup. But it wouldn't be trivial to kind of implement it into our build process to basically have Tor bundled alongside of Dash Core and then be able to just run it and activate it at the same time as Core. It's definitely not impossible. Like I said, I know other projects have done it. But I would have to see if there are any like Bitcoin code base forks that have done it, see how they've done it. It could introduce, one of the really important things about our build process and Bitcoin's build process is reproducibility and, the ability that anyone on, any x86 or ARM machine for that matter, I guess that runs Linux, but anyone that can run Linux can reproduce the exact binaries that we release, byte for byte. And that is, really important for auditability and ensuring that, what you see is what you get. Anyone could do a Guix build and call us out if their hashes are different. And internally, we do 3 or 4 different developers that provide these Guix builds. So that would be something that would be very important to investigate, is to make sure that bundling Tor could be done in a way that is fully deterministic. It might be, but that's, kind of, it's always difficult to make code deterministic. So, especially complex build processes. So changing stuff in there would be concerning. So I think that's a long-winded way to say potentially, but it's not trivial, and I'm not sure where it falls on the priority list, but it's not something that we're opposed to.
Thank you. The next question is for Brian. If Ash's team gets their part done with Dashpay, how much more work in weeks would your mobile team have?
So for Android, we are ready to go. We were in our final stages of our testing when there were some changes on on the back end side with what partner networks and whatnot that he's got going on. So we're just waiting for that to get stood up on his end. Effort after that is really just final testing on production in mainnet, and then we're good to go on Android. iOS, realistically, it's weeks, probably months away still. We have our priorities right now really are to get Dashpay up and running, and that's taking the resources that we've got right now for iOS. It's not a huge lift to get it back into the wallet, but it's just a resource constraint. So
Thank you very much. When NFT docs? Sam?
Good question. Do we not have NFT docs? Let me check. Docs.dash.org.
All right. While you are checking it, just a follow-up comment for Pasta. Mixing on Dash Qt wallet needs anonymous communications, in my opinion, especially with recent news.
Yeah, so I mean that's a big justification behind trying to get BIP 324, the version 2 P2P protocol, knocked out. Right, that would be and encryption between you and Masternode that makes it a lot better. So that's our goal, to get that wrapped up for B21.
Yeah. Getting back to Sam.
Yep, it's not there. Have to shake some people.
Right. Can you guess or guesstimate the timeline for that?
I can't because it's not my own work. So I'd have to ask them. I'll get back.
We will get back to you, TL. Thank you very much. Next question. Does Rust SDK implement an SPV? I think Łukasz left. I don't know if he's still here.
I can answer that for sure.
Thank you.
So the question was, does the Dash SDK, like the Rust SDK for platform, implement an SPV?
Exactly.
So we have to start by understanding what SPV is, right? It is a construct that is needed for proof of work based verification or proof of stake based verification under certain circumstances. Basically, to enable like clients to operate with enough backing that they would be able to trust at 100% what the network gives them. We do it differently. We actually have the security is actually also derived through SPV currently, but it's derived through SPV through core mechanisms that create the deterministic masternode lists. So once you have the deterministic masternode lists, you no longer need any SPV on platform. In platform, you just query. You just say, hey, I want this information. You just query the state, and the state will tell you back. And not the state like a government state. I mean the state of platform that we often refer to as the state. So you can say, let's imagine you want to order food. You just ask a restaurant what dishes they provide, right? Or different information like that, and you just query. For the verification of the data, how it works is that the data is given back with a proof. Inside the proof, we have a Grove DB structure containing all the information to verify that the information that you got back is not only accurate in the state, exists, but also exactly what you asked for, and that there is no other information that could replace it. There's a lot of things that went into this proof system. It's pretty advanced. Then that proof is signed with a quorum that you have previously verified through SPV or through other mechanisms. There are multiple ways to verify quorums. Currently, SPV is the one we officially support, but there could be others later down the road. For example, if people are just curious, a lot of proof of stake, like distributed proof of stake chains, actually have a mechanism where they switch from validator set to validator set, and they basically prove the switch of the validator set and basically move up the chain in chunks. That's how I think Tendermint uses that, and I think a few others. I think it's no longer called Tendermint. I think it's called Comet BFT. I hope that was a good enough explanation.
Do you see the follow-up question?
Oh, I don't see.
Yeah, but Dash SDK also contain L1 features like addresses and transactions, question mark. Where does it get info about it?
So we have multiple things out there. And if you're thinking about the JavaScript SDK, then yes, it contains information, and it actually contains connections to core that to do the SPV. If you're talking about the Rust SDK, it will eventually, but actually the connections to core are in a different library that we haven't integrated into the Rust SDK yet. And we're just going to use the other library that also connects to core, well, gets information from core that the mobile team has been working on.
Thank you very much. So I don't see any other questions. So I think we're good to wrap it up. Thanks for being here. Thanks for the questions. And we try to make sure that we will follow up the ones we couldn't answer at the moment. All right. Wish everybody a great rest of the day, and see you in 2 weeks. Thank you. Cheers. Bye-bye.